Welcome to episode 3 of the 3D printed paddleboard hydrofoil project. This video is about 3 things. First, we're going to get some FPV shots of the board in action. Then I'm going to put a giant battery on board and see how far it'll go. And then finally, I'm going to take out the servos and active stabilization system to see if I can ride this thing just like a normal e-foil board, by shifting my weight around. So let's get started.
It's so majestic. Woo! Woo! The drone just went under the sonar sensor and it made the whole board pitch up. It's a little sketch. Woo! Steep turn. Woo! It hit the sonar again. Woo! You're pinging my sonar, bro.
This is Ansel, the FPV pilot. Now he's going to try out the hydrofoil.
Haha, now I have control of Ansel's life.
Take me for a ride, Daddy. Oh my gosh, it is unstable.
This will be very interesting. I will try my hardest not to crash you, but...
Okay.
Okay, hang on, getting the hang of it.
This is so weird, just being on something that's just moving itself.
Yeah.
Yo! What the hell?
That must feel terrible. Wow, it's a fucking Bronco, man. Oh God.
With the active control system, you kind of just have to learn to turn off your natural desire to balance the board. And doing that actually kind of helps. But what doesn't help is having me try to pilot the thing from the shore, where it's really difficult to judge the exact attitude and altitude. That's where things get sketchy.
Okay. Yeah. That was super sketchy, dude. I can't see the attitude very well.
It was
So
pretty
I don't
rolly.
know what to do. Here, I'll let you try it now. So put that on your neck. Good luck. There, he's up. He's doing it.
It's flying. Man, it's a good thing I know how to fly FPV drones.
Yeah. Isn't it weird?
Super weird, dude. It's like really like flying my drone though. The controls are so similar.
Oh, you got a big piece of seaweed on one of the masts.
This is so wacky.
I know. It feels so unnatural.
It does, dude. I mean, it's not that bad though. Like, I didn't think I was gonna be able to get it first try. One of my sonars wasn't down.
Oh shit.
Whoa. That is so cool, Daniel.
Isn't that funny?
Dude, that's amazing. These motors have some freaking power in them. I just want to ride this thing all day.
Do it. Keep going. Oh, oh, oh. Barely brought it back. Oh.
It does feel really robotic. Yeah, it does. That is so f***ing cool though. I can't believe it works that well.
I know.
That's ridiculous. Yeah. When I went unstable though, it was just like, oh my gosh, there's no coming back from this.
Yeah. You really need to give it the correct roll input, otherwise it'll just...
I think that's what happened.
Like with a bike, you want to first lean left to turn right, you know?
Yep.
But with this, you can't really do that. Like, we don't have it in our muscle memory.
Yeah.
So it's just like, you're just jerking to one side. Yo, I don't know if this is gonna work. Oh, it works.
There you go.
Yeah, it's like super tail heavy. I'm having to hold a lot of down elevator. It goes so slow. Oh, I stalled. I have to get it up with the nose already down. Oh.
Next, we're going to do the endurance test to see how far this thing will go.
Wow, look what just washed up. It's kind of a windy morning, but I'm setting up the foil right now. And I'm gonna test it out with this big old battery. It's a 100 amp hour lithium iron phosphate battery, so I'm gonna see how much range that'll give us. I just spent, what, like 30 minutes getting this all set up, and now it's not even working. There's some issue with the Vesks. I'll have to go home and troubleshoot to see if it's the motors that are bad or the motor drives. They're fully potted, so I'm not sure what could have happened. But this thing was outside in the rain for a few days, so water must have seeped in somewhere. And after a day's worth of work, we're back up and running, baby. earwigs love to sleep in these holes and the bolts chase them out. I replaced 2 of the ESCs and 1 of the motors. Those seem to be working great, but the servos were twitching a lot when I powered them up, so that's a little concerning. Flip the sonars out here. I ditched the chair because the center of gravity was just too high. It just feels a lot more stable when you're sitting low. I've also got the big 100 amp hour LiFe PO4 battery in the back, so I'm thinking I might even need to sit up here, and we're up. Yeah, it does seem a little bit tail heavy. Okay, now I'm gonna slide my butt forward of this board and give it another try. So the point of today's mission is just to try and get an idea for how far we can go. That reminds me, I need to start Strava on my phone so we can track the mileage. Okay, now let's check the CG for sitting in front of this board. Okay, it's slightly nose heavy, but more or less just perfect. Then again, sitting on the board might make it just tail heavy enough so that the speed is reduced, which would be kind of nice. If I'm going for distance today, I want a slower speed, so I think that'll be more efficient. I'm expecting the foils will be fouled at some point because there's definitely some seaweed in the water. I'm gonna see if I can move my butt back a little bit to get the center of gravity a little bit further back. When I was working on it yesterday, I turned down the maximum current and the max RPM of the motors because I don't even need that much power really. Like before it was flying at half throttle and now it's flying at just above half throttle, so I could probably turn it down even further. But yeah, this thing just sips power. And I'm just putting along. I'm gonna make my way to that floating bridge over there. I just passed a shoe floating in the water. We're doing an endurance test, but this vessel is by no means set up for max efficiency right now. My battery wires are super long and sketchy. There's probably way more resistive losses than there need to be. I've got the 2 ESCs connected to the battery by like a series of janky Y connectors. I've not done any propeller efficiency testing. So don't expect the numbers that we arrive at to be representative of what a vehicle like this could be capable of in theory. What this thing really needs is for me to spend some time in the software setting up coordinated turns, because right now it still feels pretty robotic. So if I could set it up so that it's always keeping the gravity vector straight down, I think that would be really beneficial. Aha, I found the calm water. I just don't want to get too close to the bridge because there's submerged cables. Yeah, man, that's really excellent. There's just no wake. It's so graceful. There's a induced wake. I can see the bumps back there. But as far as the like mast wakes, it's very minimal. So I've got a little battery voltage indicator right there that I'm monitoring to make sure I don't run out of juice. I bet it's really wavy on the other side of this bridge because then the water will be exposed to the north wind. Should we go over there? I'm a little scared. I'm not afraid that the foils won't be able to handle it. I'm just afraid that if I set it down, the waves will swamp the electronics box. Woohoo! This is awesome. I can feel the sonar start to pick up these waves. It's kind of bouncing a little more. It's the elevator response. And I'm sure there's a change in lift. I think I reduced the PID gains, and I'm kind of thinking I shouldn't not have done that. Okay, yeah, that's what I was afraid of. Having to set it down in the choppy water. I don't know what happened there. Maybe I got some seaweed on one of the motors. It just started getting really wonky all of a sudden. I'm gonna try taking off again. There we go, okay. Yeah, let's go back to the smooth water. Woo, oh yeah, going downwind is weird. Woo, hey buoy. Whoa, my wing got way too close to the bottom of that buoy. There's a swimmer over there. The sonars definitely don't do as good of a job when you're going downwind. I think the larger amplitude of the waves as you're going downwind kind of messes with the distance reading of the sonar. Or maybe it just kind of puts it into phase with the reaction time of the vehicle. I'm not sure, but it's definitely a bit more unstable going downwind. Just going along the park here. We'll go give this fishing dock a flyby. Going over a big wake. Woo! Just doing a thermal check. These BECs are pretty warm, but they're not terribly warm. So I'm gonna head way over to that bay down there. There's definitely some weeds on it. Oh yeah, that's a beaver. Okay, let's get back up on foil. I think I'm matched exactly with the wind speed, so there's zero apparent wind to me. So it just feels perfectly calm. A lot of people sleep on their boats out here in this bay. It's the one place in the lake they let you anchor. Okay, I'm turning back into the wind and go all the way back to the boat ramp. Oh no, oh no. Oh no, I just caught a lot of seaweed there. Okay, now we've just got a long upwind. Whoops, oh, wow. Why is it so crazy? Okay, now we've just got a long upwind to push to the boat ramp.
So here's our stats. On this day I traveled 8.2 miles and consumed 1,185 watt-hours of electricity. The battery holds 2,560 watt-hours. So if I had used 100% of the battery capacity, I could have gone roughly 17 miles. The average power consumption while up on foil was 820 watts, and the overall efficiency comes out at 89 watt-hours per kilometer at 2.9 meters per second. I don't really know how that compares to a normal e-foil board, but I'm guessing it's not great. This thing is like the monster truck of the hydrofoil world. Super slow and not very efficient due to all the rough 3D printed surfaces and exposed control linkages. I calculated the power consumption by measuring how much energy the battery took back while charging after the mission, so all those numbers might not have been super accurate, and the distance was just measured with my phone, so probably also not the most accurate thing in the world.
It's a hydrofoil.
Oh, did you make it?
Yeah.
Did?
It's 3D printed.
Fabulous.
It was way cool when you came in. I was like, wow, is he riding on the top of it?
So that's an electric engine.
Yeah, 2 of them.
Yeah, we can even put fat people on those.
Next up, I wanted to mount a little underwater camera on the foil to see what there is to see. After watching the footage back, I learned my right aileron wasn't even working. No wonder the board was behaving kinda strangely during the efficiency test. The aileron was stuck in an upwards position, so the right side of the wing was making less lift, and the left aileron probably also had to hold an upwards position to compensate for it. So that's unfortunate. It would have been like flying with spoilers up the whole time. Next, I moved the camera over to the left side of the horizontal stabilizer. From here we can see that the left aileron was working. I was surprised to see how much vibration there was, considering how smooth it felt when sitting on the board. I think it was just the camera vibrating, or maybe just the horizontal stabilizer. It's cool to see the tip ventilation vortices coming off the prop when it breaches the surface. Next I wanted to do a max payload test, so I enlisted the help of Colin. He's the guy who makes the songs.
How much do you weigh, sir?
250.
250, and I'm 150. So 250 plus 150 is what? That's 400?
Yeah.
Oh, jeez. Okay, hang on, get off real quick. Or no, you're good. Holy shit, dude, you do weigh 250. Whoa, you sank the whole board. Whoa, I didn't expect that. Okay, I'm gonna try it without me real quick. I thought we were both gonna be able to ride it, but I don't know about that. Man, I really need the aileron. One of the ailerons is broken, that's why it's rolling. Okay, I think this plan is foiled. I thought I was gonna be able to sit up there and you were gonna be able to sit here and it would balance out. And I think it would work if I had both ailerons working, but I don't have enough roll control.
Yeah, 3 out of the 4 servos survived. Okay, is there any water in this thing? Let's find out. Huh, I don't see any water. Definitely smells a little funny. Here it comes. Oh yeah, there's no water in there at all. It definitely looks like these gears were under some stress because the grease is quite dark. That indicates there's metal powder. Oh yeah, the motor is completely seized up. There we go, come on. Oh yeah, yeah, that's pretty toasty. Everything around here is just melted. The windings are very toasty looking. So what we learned from this is that my control surfaces were just too big and I was pulling too much current through these servos. Oops, my bad. So yeah, the ailerons are huge, and the Epler 817 airfoil also has a cupped trailing edge, which creates more lift in the back. All this lift is just trying to rotate the aileron up, and that puts a huge amount of torque on the servo. So the servo motors were having to fight against that lift and hold the ailerons down the whole time I was riding. So they're essentially holding up a decent amount of the weight of the vehicle. So that's a bad design on my part. I totally could have made the ailerons like a quarter of their size because they had plenty of control authority to spare. But one thing that did end up working well was my waterproof servo housings. There was no sign of water ingress on any of the 4 servos, so I'll definitely use this design again in the future. Though the grease and housing probably add a lot of thermal insulation around the servos, so you have to make sure they aren't having to sustain high torque for long periods of time. If you want to download these files, you're in luck, because they're available for free at the Onshape link in the description, as well as the model of the rest of the hydrofoil. The best part is, all these files are cloud native, so you can easily make changes to suit your needs. So next I want to do a little experiment, and that is to see if I could ride this thing like a normal e-foil board, and stabilize it by shifting my weight. At this point I had taken out all the servos and I taped the control surfaces down so they were fixed in place.
So it should just start flying. Yeah, it's going. Now I just have to clear that step before the air leaks out. It's like almost neutrally buoyant. I'm gonna start sitting down just to try and figure out where the center of gravity should be. Oh yeah, this might be doable. Whoa, I just feel like I don't have much turning control. Woohoo! Yeah, look at that, I'm doing it. Given it is a dead calm day. Oh yeah, look at that. I'm just weight shifting. I can keep it going in a straight line, but I don't think I'm gonna be able to initiate turns. I can use weight shift to control the roll, but yaw does not seem to follow at all. Okay, I feel like there's no way I'm gonna be able to stand up on this thing, but we'll see. Whoa, too much. Ah! I need my ailerons back. I can definitely do pitch control, but roll is tough, man. Maybe I can use differential thrust though to yaw into the turn. No. I think it might be easier sitting down because I can kind of shift my weight more for roll. I'm trying to yaw into the roll and it'll help straighten out the roll, but it doesn't really seem to be working. I mean, I don't have any roll control, but the roll just happens to be going straight, which is nice. Woo, there was a little correction. I used the yaw to kind of yaw into the roll a little bit, and that actually, no, never mind. I don't think that works at all. Man, this is a core workout. There we go, there's a little yaw. It's all about having your balance in the right spot. I think I can control roll by leaning. It just takes a really long time. Woo, it's working. No. Man, it seems like the wind has an effect. When I go that way, it works. When I go this way, it doesn't work. There we go. Come on, all my weight is over and it's still not doing it. You wanna try it?
Yeah.
Now he's trying to do differential thrust to yaw into the roll. It only works so much.
So I think there's 3 possible reasons why roll control via weight shifting is so difficult with this thing. The first is that it's just huge. With a 7-foot wingspan, you really have to lean your body way over the edge to get any meaningful amount of leverage to muscle that big wing through the water. And that's just difficult to do when you have nothing to hold on to, and you're also trying to manage the pitch axis. The second possible reason is, it's a heavy inverted pendulum. The center of gravity is way up here, and the center of lift is way down here. That makes it so that when the roll axis starts to deviate from the center, it's really hard to bring it back because there's already so much weight off to the side of the center of gravity. You'd have to be able to lean way over the edge to bring it back to center. That brings up the question, how are people able to ride normal hydrofoil surfboards, since they also have the center of gravity way above the center of lift? It's doable because those hydrofoils are relatively small and agile, so it's easier for the rider to always keep the foil directly under their body weight. And when they're ready to turn, they can steer the foil out from underneath their body weight so that the whole inverted pendulum starts to lean over. It's really similar to riding a bike. In order to turn left, you first have to turn right to initiate the whole inverted pendulum to start to lean to the left. Then once you're leaning left, you just have to balance it at that angle to continue the turn. The third possible reason as to why the roll axis is so difficult to control is that there is pretty much zero roll-to-yaw coupling. With a normal hydrofoil board, the mast kind of acts like the vertical stabilizer on an airplane. Even though it's not way back on the tail, it still has the same effect because it's still behind the center of pressure. This leads to good yaw stability and some roll-to-yaw coupling. When the board starts to roll to one side, the yaw will follow a little bit. Now my hydrofoil has the masts right over the top of the wing, so they're probably too close to the center of pressure to result in any good roll-to-yaw coupling. So when the board leans over to one side, it just keeps going straight. The yaw doesn't really follow the roll. In fact, there might even be some inverse roll-to-yaw coupling. In a few of the clips, it kind of looks like the board might even be yawing away from the roll. If this is really its natural tendency, it would make the board extra difficult to ride, since it would always be trying to yaw out from underneath you. To test this theory, I decided to add a vertical stabilizer. That just slots into the spar tubes in the middle of the horizontal stabilizer. And to scramble up all our variables and make things even more confusing, I also made some software changes. So I reprogrammed the flight controller to have a roll to yaw mix now. So watch, when I lean over to this side, now the differential thrust just turned the board to this way, to the right. So when I lean to the right, it turns to the right. And that's to hopefully get it to self-stabilize a little bit. If I lean to the left, the board will yaw to the left automatically. It's kind of cool. It might actually be working. Holy crap, I didn't think it would work. Now, but I'm in the mode with the IMU angle mix, and I don't know if that's what's doing it or if the tail fin is what's doing it. Woo! Oh no, it's turning a lot now. Woohoo! Ooh, got some waves. Going over waves. Oh, okay. It's definitely not perfect still. Okay, now I'm gonna turn it
out of that stabilized mode, so it's just raw again. No stabilization, it's just me. I think it's better. I think it works. Yeah, man, it feels pretty good. Now leaning, okay, let's see. Oh, maybe not. Maybe I still don't have as much authority as I need, but it definitely felt better. Come on, baby, come on, turn. Wow, it turns so slowly. I had my weight all the way off to the other side. I think that there's not really a chance I could stand on it, because if I'm standing, I'm just not able to shift my weight enough. Better, but still not perfect. I was leaning a lot, and it like super slowly corrects.
One of those things up under ours too.
That'd be cool.
So unfortunately, one of the motor drivers eventually stopped working, so we weren't able to spend a lot of time testing it, but it did seem like the addition of the vertical stabilizer helped a little bit. Definitely not a cure-all, it was still really hard to balance the roll axis. The active stabilization and servo control that I had before was really necessary for this board to be practical, especially the ailerons. I find all these hydrofoil experiments to be extremely fun and interesting, and I've learned a lot. Doing some investigative disassembly, and I just removed this bolt, and there's water in the hole.
There was water coming out of the phase wire area, so that's a bad sign. Oh, there's some. As I was setting up this board to ride with just weight shifting only, no active stabilization from the control surfaces, I was testing out the motors, and I realized that these ESCs are not working. These are the big Vesk or Flip Sky 75 200s, and they were making the motors stutter a lot. And I saw a bunch of corrosion where the phase wires and the power wires enter, so they must be water damaged. It's kind of misleading because you would think that they're waterproof. They have water cooling inlets. Everything is potted. If you take off the front cover, it looks like this inside, fully potted. I've been picking away the silicone rubber stuff right here. It's just a circuit board, so I can't really see what's going on where the phase wires enter. So I'm just gonna take a big saw and just cut this thing in half so we can get a peek at what's going on in there. The problem with this approach is that the aluminum got so hot from the saw that any water in there would have just boiled away. So it really is just a solid block of aluminum at the bottom, and it's not fully potted, it looks like. There's a lot of voids in there, so that's probably where water got in somehow. Wow, this thing here is the PCB. That's like a 4mm thick aluminum PCB. It's hard to tell what's corrosion and what just got all messed up when I cut through it. Oh yeah, there's the good stuff. I do see some little bits of green. Could be corrosion. Oh yeah, there's the power stage. Wow, that's a lot of goop under there. Definitely looks a little bit like corrosion. With the other damaged motor drive, I was able to cut it lengthwise and extract the PCBs without ruining them. So hopefully this one isn't ruined and I can use it again in the future. So the logic is on this top PCB, the power stage is on the bottom, and I think the power stage was what was all wet. And the current sense resistors were wet, and that was throwing off the motor drive. I don't know, I'm just going to try this. I'm just going to give it a positive angle of attack and just pull. Oh yeah, look at that, it's flying right up. Woo! No way, that worked so well. Oh, that was awesome. That brings us to the end of this project. It's been super fun, and I hope to build something similar for next summer. Thanks for watching, bye.